We're going to take a look at some factoring situations that might be challenging to some of us. Specifically, those situations are when our a value is greater than 1. So what do I mean by that? Well, I'm talking about whenever I have a trinomial in standard form, my a value here is this coefficient here on my x squared term. And so whenever that is greater than 1, it doesn't factor as easily as just having two binomials let's use some different letters, in this form. Because what happens is that I end up needing coefficients here on my x terms so that I can have this a value that's greater than 1. So there's a couple different ways that we can go about doing this. We're going to take a look at kind of a procedural method. That's the second thing we're going to do, but then just kind of like the general way of thinking about these. So I'm going to make up a problem here. Let's see. The problem is going to be 6x squared minus 23x minus 4. All right, so the challenge here is that I want to factor this into something that looks like this. And so normally what I would do is I'm looking for numbers that multiply to be -4 and add to be -23. But the 6 throws me off. And so what I actually have to do is look for two numbers, or actually 4 total numbers, 2 that multiply to be 4 and 2 that multiply to be 6. But then when I multiply them and add them in some combination, they give me -23. So what I mean by that is, so if I have a factored trinomial into these two binomials here, what I get when I expand this out is I get a times cx squared plus, and then b times cx, and a times dx plus bd. So what this is a really complicated way of saying is that my a and c terms have to multiply to be my coefficient on the x squared. My b, c, a, and d terms have to multiply in this fashion and then be added together to give me the coefficient on my x term, and then my b and d terms have to multiply to give me this product here, this constant. And so this is kind of a lot of mental math to keep track of in our heads, and so for some of us it might just be easier to proceduralize this, but if we can just kind of, I don't like calling it this, but the guess and check method, kind of like going through the possibilities, then that's ideal. So let's take a look at what we need to do is we need to look at the factors of 6 and the factors of 4 here. So my factors of 6 are 1 and 6 and 2 and 3. And my factors of 4, and really I should look at the factors of -4, are 1 and -4, -1 and 4, and then -2 and 2 are my potential factors of -4, if this factors into integer values. And so I have to think to myself, I need coefficients on the x's, so a and c here, they're either 1 and 6 and 2 and 3, or I need b and d to be a pair of coefficients here, such that when I add them together, I end up getting this -23. And so I could try out some of these. What I'm noticing here is that -23 is a pretty big number relative to these. And so there's only one way that I can get anywhere close to that. And where it's going to be is with my 6 and -4 here. If I take 6 times -4, that gives me -24, and then my 1 times my 1, it gets me 1, which is -23. And so that's going to be what my target is. And so the question is, I just need to make sure I arrange these correctly. So if I arrange these correctly, what I'll end up getting is that, so I know my coefficients on x are going to be 6 and 1, so I need 6x in one of them and x in the other. And then I need my -4 to be multiplied by my 6, which means it needs to go over here in this binomial, and then my 1 needs to go over here. Okay, because I'm matching these up because these are the ones that get multiplied and these are the ones that get multiplied. And so just to make sure I can expand this out, 6x times x is 6x squared. 6x times -4 is -24x. 1 times x is just 1x. and then 1 times negative 4 is negative 4. And so I do in fact get my original, oh darn, I do in fact get my original trinomial, which is what I wanted. So this is my factored form. So I did get it right, which is good. But so this is, yeah, it requires me to kind of be able to think through these numbers and do a little, mental math here. So the question is, if I wanted to, how could I just proceduralize this so that I don't have to do much thinking, of which, again, this isn't maybe ideal, but, it's a way of getting things done if I get stuck. So let's go ahead and get rid of this. Let's pick up a new problem then. So here's a new one. This is just randomly generating. I got another 6x squared plus 23x and then minus 35. Okay, so how can I do this? Well, what I'm going to look at are a couple different things. I'm going to look at what I'm going to call my product, and I'm going to look at my sum. So my sum in this case is easy. It's 23. It's this is coefficient here on my x term is 23, and my product I do is a little bit of work to do. It's going to be my 6 and negative 35, those multiplied together. So when I multiply those together, what I get is negative 210. I hope 6 times 35. That's 70 times. Yeah. Okay, that checks out. So here's what I'm trying to do now. Now I'm trying to think of numbers that multiply to be negative 210 and add to be 23. So I'm going to make my list here of factors of 210. Okay, so I got 1 and 210. Hopefully it's not that. 2, and then I have 105. I have 3 and 70. 4 doesn't work, 5 does though. That's 5 and 42. 6 works. 6 goes in there. 30, 35 times. Oh yeah, 30, because those are numbers that multiply together. Yeah, that makes sense. 7 goes in there 21 times. 8 doesn't look good. 50, no. 9 is no good. 10 is good though. This is 10. Wait. What did I do? Oh, this is 7, 30. Yeah, I was dumb. Quick eraser. Actually, let's just undo. 7 and 30. And then 10 and 21. I was just thinking a step ahead. Alright, and then, do I have any more? 11's no good. 12, no. 13, no. 14. 14 goes in there, maybe. 14 would go in there 5 times. No, 14 goes in there 170, 15 times. Alright, that has got to be the end of my list. So now I'm looking for two numbers here so it's technically not their sum here. It's going to be their difference, because one of these has to be negative. That gets me to 23. Okay, so in that case, that is 7 and 30. Okay, so what I've kind of done is I've turned this into what factoring looks like whenever my a value is not greater than 1, when it's just equal to 1. I've multiplied these together. I found their product. This is my sum. And so now I'm just looking for two numbers that multiply to be this and add to be 23. So those two numbers are going to be 30 and negative 7. So here's what I'm going to do. And this is where it's kind of gets a little bit tricky, but here's the procedure. I'm going to take the 6x squared. I'm going to break up my x term into 30x and negative 7x. Because I can do that because 23x is just 30x minus 7x. And then I can subtract the 35. So here's what I can do. And this is why it kind of works out, is that I can then look at my first two terms and factor out a greatest common factor here. From these two terms, my greatest common factor is 6x. I can factor out 6x from both of them. What I'm left with then is x here and 5 here. And then over here I can factor out negative 7. Negative 7. So what I'm left with is x plus 5. And so what I'm doing is I'm factoring by grouping here. And because I picked these numbers correctly, what ends up happening is that I have the same thing that's left over when I factor out these terms. And so when I go to now I can factor this by grouping. I can factor out the x plus 5 from each, and what I'm left with then is this factored form: x plus 5 times 6x minus 7. Okay, so this procedure can, if I ever get stuck, can help me out along the way. And so let's just run through it one more time with this. What I found was I found my product here, which was my a term and my c term multiplied together. I found my sum, which was just this coefficient here on the x term. I went through and found two numbers that multiplied to be negative 210 and then added to be 23, with one of them being negative in this case. I broke up my coefficient on the x term into the two terms that add to be this. So 30x and negative 7x, those are two values I found before. And I factored out a greatest common factor from the first two terms and last two terms, and last but not least, then I factored by grouping. And so this was just a way that I can, again, kind of proceduralize this and get to my answer. So maybe we'll run through one more just to re-emphasize this. Another random problem. Oh man, another random problem. Got 6x squared again. All right, so 6x squared plus 37x plus 35. Okay, so we're going to do the same thing. My sum, again, is 37. And then my product, well, I can already do this one. My product is 210. And so I can just list out the factors again. Hopefully I don't make mistakes since I just did this. 1, 210. I had 2, 105. I had 3 and 70. 4 didn't work, but 5 did. It goes in there 42 times. 6 worked, right? Yeah, 6 and 35. Yep, and I did the same thing as last time. 7 and 30. 8 doesn't work. 9 doesn't work. 10 does, though. And that's 10 and 21. And then I don't think, 12 doesn't work. 13, 14 is the last one. It works out with 15. All right, so now I'm looking for two numbers here that add to be 37. They're right here, 30 and 7. So what I'm going to do is I'm going to write this down again, but breaking up the 37x. The interesting thing is it doesn't matter which order I put these in. The factoring by grouping will work either way. It just kind of switches which thing I'm factoring out. But so I can separate out like this. And then I can look and see what's my greatest common factor here. My greatest common factor is going to be 6x for these first two terms. So I'm left with x. I'm left with 5. And then my 7 is the greatest term over here. 7 times x plus 5 again. And so when I factor out the x plus 5, I get x plus 5 times 6x plus 7. All right. So that's just a procedure we can run through to factor out these trinomials that have an a value greater than 1. It works for me whenever I get stuck and I can't just guess and check my way through. So there's a couple different ways of doing this. Whatever works for you is just fine.